So good afternoon, and thank you for the introduction. I'm very happy to be here at the Academy, giving you a small update on some of the activities that are going on some of the decisions also that have been made recently in Sevilla in particular, but also what is at stake in space in Europe at the moment, and what is keeping us busy, what is driving space in Europe at the moment. So I've put a few slides together just to recall some of the points, some of the information you may know. Some of it may be more new, but just to give a brief update on some of the elements that are at stake. Of course, just one slide, but there is no point to really introducing ESA. You know it very well. But let me go to some of the more factual elements of it. So what you see here is the budget of ESA, how we are spending the budget on the different programs. Maybe important to recall, but many of you would remember the various activities that are funded through the ministerial conferences. So we have the largest, I would say still, or by far the largest program is Earth observation. Earth observation, as you know, has a number of lines. Of course, the Copernicus budget, the Copernicus program on one side, but also the Future EO, which is the envelope program, used to be called EOE3, EOEP, Earth Observation Envelope Program. But Future EO is having the Earth Explorers, the ground segment, the technology development, and the data utilization component. And then there are many other Earth observation programs in addition, together with EUMETSAT, but also smaller missions, climate missions, and so on. Then we have, of course, telecom is a relatively large activity. Navigation, again, navigation, obviously the implementation of Galileo, but also some activities within the ESA program like NAVISP. Launches, quite important, Ariane 5 or the Ariane and Vega program, I should say, plus future transportation, and the Kourou Space Center, which you see here also in terms of budgets. And space science, obviously, a very large amount as well, which is about 9%, and what is here is human spaceflight, microgravity, and exploration. So this is the side of how the money is spent and allocated to programs. How is the money coming in? As you know, we get the ministerial conferences where the member states are signing up to the programs. We get about 2/3 of the budget from member states through ministerial conferences. About 1/4, or almost 1/4, 24% coming from the European Union. This is this year's budget. The numbers are slightly changing in different years. Then we have a relatively large portion, what is called other income. Other income are agreements which ESA is making with third parties. For example, countries. We have made a very large agreement with Italy, 1.4 billion for Earth observation and launches, but also Greece, Spain, and some other countries where we have third-party agreements one-to-one, where we implement for a country on a national basis these activities. And then EUMETSAT this year is a bit smaller, only 1.8%, but in some years this contribution is much larger. France, of course, a very big contributor, 20%, as you see here, 1 billion this year. It was a little more last year. Germany, of course, being the other large contributor, Italy, UK being the big member states, and then, of course, having a number of medium-sized and smaller member states. So quite important to recall, about 2/3 is coming through the optional programs, ministerial conferences, as we had the one last year. Last year, as you know, we had a 17% increase of budget. You have all followed this in the news, 17% increase in times of war, in times of very high inflation. Just after COVID, this was a major achievement, and European decision makers, ministers have really recognized the importance of space and therefore really invested significantly into the ESA programs. The next one is recalling some of the highlights of where Europe is really good and where Europe has developed some of the best programs worldwide. I take Copernicus and Galileo as two examples which we implement together with the European Commission, but also obviously with industry, with the member states, to develop top-level programs. If I talk of these two flagship programs, Galileo Copernicus, it is worth recalling that in both programs, Europe was really catching up after a few decades of activities or leadership by other countries, in particular the United States, for example, through the GPS program. Europe has decided in the 90s to build up its own navigation program, Galileo, which today is delivering the most accurate signal worldwide compared to all other programs. And I think this shows that Europe, if you put your act together, if you unite your forces, if you bring together the expertise of the European Space Agency with the European Commission's strength and expertise, with the member states, with industry, we can develop world-class programs, and this is one good example. Copernicus is another one. Again, in Copernicus, very similar situation. Since 1972, the world was really depending on data from Landsat, the Landsat missions of the United States. Fantastic missions, fantastic data used for land mapping in particular. I've done my own PhD on, based on Landsat data. It's a very important data set until the 80s and 90s, when Europe then decided to step in. Of course, Spot 1 was launched in the mid-80s, ERS-1 in 91, ERS-2 in 96. So there Europe built up its own Earth observation program. Then ENVISAT came, and of course the Copernicus program, which was initiated in 1998. Now we have 25 years of Copernicus, which is yet again an example of success, where Europe, with 20 years or so delay, started building up its own program, and today has one of the world's best programs, top-class program in Earth observation, monitoring the pulse of our planet for climate, for agriculture, for forestry, for ship routing, for many applications, disaster management, and many applications which we have developed through the Copernicus program. So I think these are good examples, and what I want to say with this is, when Europe puts its energy together, then we can do it. We can do it if we unite the forces of the various institutions, Commission, ESA, and obviously member states and industry. Of course, you are very familiar with other programs, ARTES, the Webb Space Telescope. Just to recall that Europe, ESA, was launching this 10 billion space telescope, which is quite an honor that NASA is putting ESA in charge of launching it. The insertion into the orbit was so precise that the lifetime or the life expectancy of the James Webb Space Telescope is doubled, or more than doubled. It was conceived, or it was expected to be for 10 years, but since there was no or very little fuel needed to come to the final destination, we expect today that the James Webb Space Telescope will run for more than 20 years. So thanks to Ariane 5, the lifetime was really more than doubled, or will be more than doubled, of the James Webb Space Telescope. But also Europe is providing 1.5 out of 4 instruments. We have also a very strong science team, so we are a very strong partner, not only launching it into space, but also in the science part and the instrumentation part. Rosetta, some of you may remember, landing on a comet. This was quite a unique landing in 2014, and really is one of the highlights of space in Europe. But let me remind everyone, and of course here in Toulouse, this is not news to you. You're very familiar with the strength of France in space, of course through CNES, very strong space agency, obviously also within the ESA context. You have the Space Command as a very strong space command that is being built up, and really congratulations to France of reinforcing and recognizing the importance of it. And Kourou, which is our launch base, our European spaceport, which we use since many decades very successfully, but we have new arrangements planned now also thanks to the decisions made in Sevilla. Tonight, as some of you may know, we have a very important test of the engine, of the Vulcan 2.1 engine, main stage, which is called the combined test hot firing, which is taking place at 9:15 tonight. It will be live broadcast, so if you want to follow it on the internet, you can see it. It will be 470 seconds, about 8 minutes, simulating a full flight of the first stage of Ariane 6. And this is a very fundamental, a very important test. It's also the biggest test of the first stage, and of course, depending on the data, which we will evaluate in the next couple of days, I will then be in a position to announce a launch date for Ariane 6. So far, I've only said it will be in 2024, but which month we will be able to consolidate after the test result. We plan a press conference at the end of November when I plan to announce the launch date. So don't ask me today because we don't know yet. We have to wait for the test. Fingers crossed for tonight, but this is a very fundamental, a very important test. Then France, of course, as you know very well, is extremely well engaged in many of the ESA programs. You see here some of the examples where French participation is very strong, but there are many, many, many more satellites and missions where, of course, French technology from French industry is included. As you see some of the examples, we have launched JUICE this year, then the Novacom series, Earth Return Orbit, Copernicus, METOP-SG, Prometheus. These are some of the examples where France has a very strong industrial role, but also in science and the use of data. France is classically a very, very strong space power. And really, let me use the occasion to also thank France collectively for its strong engagement in ESA. The last ministerial conference, France has increased its subscription in the ESA context by 24% compared to 3 years earlier, compared to 2019. Very strong participation in many programs, obviously Launcher, but also many other programs, and really appreciate this strong engagement and very happy to be a strong agency also for the interest of France. What you see here are some examples of some of the highlights which we had this year. You see the launches of Euclid and JUICE, which took place earlier this year. JUICE investigating the icy moons of Jupiter. There are 3 of those which we're investigating. And we are looking at the habitability of these icy moons. In other words, is the environment good to find possible traces of life, maybe underground? Underground means, in this case, under a very thick ice cover. We assume that there's on some of the moons about 100-kilometer thick ice layer, and underneath we have oceans, there's water, and there could be some forms of life which we do not know today. And JUICE will look whether these planets would be habitable, what the conditions are, what the environment is, in order to see whether or not. Maybe later on we send a mission there to really take a probe and see and find out a bit more in detail. But this is quite a fascinating mission. The mission was launched this year, will arrive in Jupiter in 2031, and then, of course, collect the data. Another mission, and you may have seen the first example of the science data published on the day of the Seville summit, is Euclid. Euclid is an amazing mission from a technology point of view, but also from a science point of view. From a technology point of view, the instrumentation is really top standard, is very strong in terms of capabilities of the instruments. But the science is even more fascinating because it is investigating dark energy, dark matter, and this is something that is a bit mysterious because we cannot measure it today. There's theories that assume that there must be dark energy and there must be dark matter in order to explain some of the phenomena of our universe, but we have not measured it yet, and this makes 95% of our universe. 95% of our universe is dark matter, dark energy, and only 5% of our universe is what we see, what we can see with the stars and everything on our planet, which is quite amazing. We have just published the first image. You have probably seen it in the news, and it really will unravel some of these mysteries and some of these secrets of the universe to hopefully better understand how this dark energy functions. Dark energy meaning that we know that the universe is expanding, but it's not expanding linearly, it's expanding faster, and that means there must be an acceleration, so a force, an energy that makes the universe to expand faster, and this is what scientists call dark energy, and this is what we would like to understand, what is the size, how does it function, or how could it function, and to really understand much more of this. So really fascinating mission. Andy Morgensen is our astronaut in space at the moment. He is a commander of the space station, and when his term finishes, that means his duration is about 6 months, he will be the longest serving European commander of the space station. He was also the pilot of the US Crew Dragon, the first time ever that a non-United States astronaut is a pilot of the Crew Dragon. So very big honors that are given to us by NASA and the other partners of the space station. Thanks also to our strong participation in the program. And Andy Morgensen is doing a really good job in terms of all the experiments, all the science that is being conducted in the space station. Also, our new astronauts, as you see here, have been picked. They have been selected in November last year at the ministerial conference, but they have now started their baseline training. So we have 5 astronauts of the 17 that have been selected now in training, and they will become the next generation of astronauts going to the space station, in addition to the existing ones that we have. Space Summit in Sevilla, I will say a few more words in a minute, but this was obviously one of the highlights more from a political point of view for us. So what you see here is the astronauts as they're starting their training. This is at the European Astronaut Center, really a very good and motivated group of people. You see them together here with Alexander Gerst, and they're really going through the various steps. I've just spoken to them this week. They are very keen on finding opportunities. As you know, we have these 5 in training for long duration missions in the space station. In addition, 2 of the reserve astronauts get flight opportunities to fly on an Axiom flight for about 10 to 12 days. One of them is the Swedish reserve astronaut Marcus Wandt, who will fly in early January to the space station through the Axiom arrangement. What you see here is JUICE. I already mentioned the mission, which is a really fascinating mission in terms of its instrumentation, in terms of its technology. 10 instruments on board, measuring different aspects of the icy moons in different layers, looking into the ice layer, and therefore really being able to understand how these moons are functioning and how they are working, and whether, as I said before, they could be habitable or not. This is the very first Euclid image, fascinating image. There have been a couple of them presented to the science community. They have really made headlines in different places in the world, in cover pages of the New York Times. I have seen one photo sent to me by some colleague who has been seeing this image at a bus station in Japan, in Tokyo. So it really spread all across the world, obviously in Europe, but also outside Europe, and really was a very important image. I would expect that the science based on these Euclid measurements will create also some Nobel Prize winners, because we're looking so deep into the various elements of the existence of our universe, the expansion of our universe, and how the universe functions. This will certainly create quite a lot of also groundbreaking science. Here you see Andy Morgensen when the key is handed over to him as being the commander of the space station as part of his Hugin mission, which he is conducting. Also, just to recall, and this is something that you are very familiar with, that the commercialization is really going very fast now across the world. If you look at the United States, also how much private funding is flowing into space, it's touching a number of domains where commercialization is very strong. Also in ESA, obviously we take this as a priority. I see Magali Vesser in the audience here, who has been one of the pioneers within ESA to put commercialization really very high on the agenda, and work with private industry to see what ESA can do in order to develop and foster private industry's interests, and therefore commercialize space much more. Of course, many of these domains are now really coming very strong. We have climate, we have in-orbit servicing, space connectivity, exploration, where more and more private money flows in. Globally speaking, just to give you the figures which we have, the space economy today globally is expected to be around $460 billion, and this 460 euros is almost a 1-to-1 ratio. This 460 billion will expand to about $1 trillion dollars or euros in the next decade. So it's a really fast-growing economy that we have ahead of us, which of course comprises the hardware and the downstream sector as well. In terms of public investments, globally we have about $100 billion that are spent on space, most of it from the United States. NASA has a very substantive budget of, so NASA and the Space Force together, 45 billion. In Europe, collectively, we have about 14 billion, 13 to 14 billion, so 13 to 14% of the global figure. But the private sector is now really picking up, and we have a global investment in 2023 of about 9 billion private funding going into space, of which in Europe we have about 1 billion. So in the private sector or private money in space, Europe is a little bit behind compared to the public investments, and this is something where Europe has to catch up and really increase its investments in the space sector. And this is certainly one of the priorities which I have on my own side. What you see here are some of these figures, but also on the left-hand side, just looking at the number of satellites that are being counted or being expected, and you see how steep these numbers are increasing in the next years. So really, in other words, the space sector is really growing extremely fast and is developing very nicely from many parameters you look. Of course, with all its pros and cons, as you can imagine, many elements need to be considered a bit with caution. Here's the commercialization. So what do we do in Europe and within ESA? What I have done since I became DG 2.5 years ago, first of all, we have really highlighted commercialization as a priority in Agenda 2025, which is our strategy document of ESA and its member states. I've created a directorate called Commercialization, Industry and Competitiveness. Geraldine Nascher is the director of this directorate, and they really focus on many, many aspects on commercialization. One of them you see here are the partnerships with venture capital companies. I have signed 29 venture capital agreements or agreements with venture capital companies where they are willing to provide money to the space sector. Obviously, we provide access to the space community. We organize matchmaking activities. We identify projects and activities where we can fund technology and mature technology to make it more commercially interesting for commercial partners. And the commercial partners, the venture capital funds, are ready to invest in these companies and really develop the commercial sector also at European level. I also have an agreement which is about to be signed with the European Investment Fund and another one with a broker, again, to really support the commercialization aspects. We're having 29 BICs across Europe, which is a very large number with more than 1,400 startups that are working and that are being created through this mechanism. ESA Agenda 2025, I mentioned already with the priorities, one of them being commercialization, ESA-EU relationship being another one where, of course, the forces of the European Union with its institutions, the European Commission in particular, and us, ESA, need to be reinforced. We have flagship programs. Of course, IRIS² is the next one that is on the horizon where we have to work together to implement it. Safety security, obviously another priority which we are working at. Program challenges, this means programs like Ariane 6, broadband internet and other programs where we really need to focus on. And ESA transformation, also internally in ESA, I'm going through a very large transformation process with our people in order to see how we can be more agile, faster, more dynamic, more responsive, reduce bureaucracy, of course keeping accountability and quality of our outputs, of our missions, of our satellites, but really see how we can be much leaner in the way how we implement. And this is certainly something where we need to work a lot. And I'm just getting recommendations from my internal working groups. About 200 people have been working on actively in working groups over this year with the help also of an external consultant. We are now going to implement these recommendations in the next year to really rejuvenate and modernize ESA in many aspects to be much more responsive to the needs of industry. Where is Europe strong and where is Europe weaker? Of course, you know the strengths of Europe. I mentioned them at the beginning. Earth observation, Copernicus, Galileo, space science, we are really top level compared to other nations around Europe. That means US, China, or other countries. But also we have domains where we really need to catch up or really make sure that we are not losing track and therefore not thrown out of the race. launches certainly is our biggest challenge we have today, a huge issue that we have to resolve. Today we do not have a launcher, a European launcher to launch our satellites. This is a crisis, as I called it, and we have to tackle it head on. I was on one side making sure that Ariane 6 goes to the launch pad as quick as we can, and I mentioned before the hot firing test we have tonight, and certainly something that is using a lot of our time and our energy to ensure that we have Ariane 6 and also Vega C back on the launch pad. But then we made the decisions of Sevilla, I will explain them in a minute, which really bring us forward, and I think in a very good path out of this launcher crisis. Broadband internet, thanks to the Commission, we have IRIS², which is being put together. This is something we do for the Commission. The Commission is leading. I see Mrs. Cavada here in the audience. Very busy putting this industrial consortium together. We as ESA, we are supporting the Commission in implementation, but also we have an ESA program, 640 million, which have been subscribed by the member states that are being part of this overall IRIS² consortium, and where we focus on development of R&D work, but also the validation of the activities. And exploration, obviously, is the other domain where Europe really needs to catch up. Exploration, as you know, we have a situation where Europe today is not capable of flying its own astronauts into space. We are flying with NASA, or NASA is providing launches through SpaceX. It works well. We have a very good partnership, but the question is, should Europe keep relying on an external partner? The other nations capable of flying astronauts to space are obviously the United States and Russia since a very long time, since the 60s. But China very recently has really shown very strongly how capable it is to not only fly to space, but also build up a space station and eventually have missions to the moon. The next nation which will fly astronauts to space is India. And India is becoming a very strong space nation. We expect that India will fly astronauts to space in probably 2 years. And Europe, what is Europe doing? Today we are not capable of flying our own astronauts. And this is a big question which we have, a question I'm asking to politicians, to decision makers, to my member states. How shall Europe position itself in this global picture? And this is where we come to the Space Summit in Sevilla just about 2 weeks ago. This was a very, very important event. Many people don't realize how significant it was in shaping the future of space in Europe. And there were many aspects that we have been deciding, and we have been defining the way forward for Europe. On the left-hand side, you see Space for a Green Future and Sustainability. Very important decisions were made on how we much better, much more intensely use space for climate change, for climate action, to really make sure that all the efforts on decarbonizing our economy, being climate neutral by 2050, how we can use space assets to do that. Space, for example, to optimize flight routes and therefore reduce carbon emissions. Space also to be used to optimize the position of wind parks, of photovoltaic plants, or many other things where the economy is transforming from one state into a more carbon-free state, and therefore space can be one source of information, not the only one obviously, but one source that can really support this process. So I've signed a joint statement with the DG of DG Climate, Kurt Vandenberge, just before the Space Summit. This was announced as one major initiative where we develop these accelerators in order to use space much more widely for sustainability. Another element was we have tabled a zero debris charter. Debris is a big issue. Today we get more and more satellites into orbit. We have about 8,000 satellites that are in orbit today. You have seen before the numbers how sharp this is increasing. We need to make sure that at the end of the life, we are taking out the satellites when they have served their duty and at the end of the life. Meaning that we would like to oblige those who are signing up to this charter that they commit themselves to take out the satellite at the end of its life. How can you do that? Of course, you need to make sure from an engineering point of view to have some fuel foreseen at the end of the satellite's life so that you can deorbit the satellite and therefore it will burn up in the atmosphere. The platform has to be made in a way that it breaks up in small enough pieces that they are all burning up and nothing comes down to the surface. So this needs a bit of engineering. We would like to standardize these elements in our platforms and therefore make it relatively cheap to implement. But it also needs regulation and regulatory forces, and again, there we will work hand in hand with the European Commission, which can put regulatory measures in place in order to really make sure that this happens widely across Europe, but also maybe for those which offer services and data to European customers. For ESA, I've already instructed my own people that our satellites will have this capability and will deorbit the satellite at the end of its life. So for ESA, it is already implemented as a standard. Then we made big decisions on access to space and space exploration. And let me just go into those. So this is once more the green transition I just mentioned. I can skip this slide. But on launches or on space transportation, we made two, or actually three, really big decisions. The first one is that we make sure that we have Ariane 6 and Vega C launches available. And if I say that, it may sound a bit surprising, but you may know that today we had only 15 launches available of Ariane 6. 15 launches, which makes about 2.5 years of operation. We did not have, because the business case was not closing, any launcher beyond that. So that means Ariane Group was not allowed to produce and instruct its subcontractors to produce new launchers, which would have meant that in Europe we have no launcher in 2027, 28, 29 and beyond. And this, of course, is not a good situation. As you can imagine, the same more or less applies to Vega C. So what we have managed is that the member states of ESA collectively have agreed on a certain support given to industry in order to close the business case and therefore be able to buy new launchers, produce new launchers from FM16, that means the 16th launcher onwards, up to 42, which brings us to the end of this decade. And this is a big step, because now we have a launcher. If we have new constellations like IRIS², Copernicus, Galileo, ESA satellites, EUMETSAT satellites, national satellites, we have now a launcher that is guaranteed, where we have, where now industry can instruct, can build through its own activities, but also instruct its subcontractors to build a launcher. So now we have a launcher guaranteed certainly for this decade and actually into early next decade. And the same applies for Vega C, so both launchers, heavy launcher and medium class launcher. And this was a very, very important decision made by our member states. And if I underline important 3 times, it means also that the negotiation to get there was not easy, as you can imagine, because there are financial commitments included, and they are significant, and this is something where I'm very happy that we could reach this deal. The second very important agreement we reached on launches is that the next generation, after Ariane 6, will be developed in a very different way. In a very different way, based on a challenge. We will launch a launcher challenge, meaning that we will offer funding for winners of future launches. Of course, they will start with in a small segment with a few hundred kilos of payload. They will probably grow to 1 ton, maybe 2 tons later on, eventually 5 tons, and eventually becoming a heavy launcher. This will take time. It will take probably 7, 8, 9 years. We do not know. But we as ESA, we will nurture this process and develop this process through this launcher challenge. The first time we will ask money to do that is at the Ministerial 2025. It's already foreseen how much money is planned for each of these winners of this launcher challenge. And of course, we will be an anchor customer. That means we will buy the launch services. We will coordinate with the European Commission, with other customers, that we have a unified portfolio where we will, through our anchor customer power, help developing a competition of launchers. Today we have in fact, ESA has launched an interest to the launcher companies to submit proposals of who would be interested to participate in a future challenge. We have received more than 20 responses, but I would say the ones that are more serious are probably in the 1-digit domain, something between, I don't know, half a dozen to 1 dozen of launches, where we believe that they will fly in the next couple of years. Of course, they are small, because they are mostly micro and mini launchers, but they will grow over the years, and this is a process that we will support and develop. In fact, what we are doing now, and the decision of Sevilla, is exactly what the United States has done through the COTS program, out of which, as we know, SpaceX has developed the Falcon 9 launcher, which today is really dominating the launcher market. So we also apply the same principles, of course, adapted to European conditions, but through a challenge to develop a cost-efficient launcher where industry can be free in order to offer its industrial capability. There will be, in terms of the way how they put their consortia together, we will give them much more freedom. Of course, a lot of discussion has yet to take place because the challenge will be prepared for the ministerial 2025. But I think the direction is clear, and now we have to start implementing it and really see how this works. And this was really a big decision. We have also decided that the launch board, our European launch board in Kourou, will have availability for these future launches for Vega C, Vega E on one side, but also for the new micro launchers and mini launchers and heavy launcher that will be created. There's an allocation of some of the unused launch pads to future launchers, which has also been part of this agreement. So this really, I think, was a very important and big milestone for Europe. On one side, guaranteeing access to space, but also preparing the future of the next generation launchers. On exploration, similarly as in launchers, we have also made a decision to have a challenge for a future cargo vehicle. A cargo vehicle that brings up to the space station about roughly 4 tons of mass, is docking on the space station, of course unloading the cargo, and is bringing back, say, 2 tons of cargo back to the Earth's surface. And this, of course, is a very important aspect. On one side, we do not have this capability today to have a transport and re-entry capability. We had ATV, as some of you may remember, but ATV was only one way. It was going up to the space station, docking, and then burning up in the atmosphere, but did not land on our surface. So we need to have this re-entry capability, which, of course, is a precondition also for future human transport. If you want to fly astronauts, obviously you need the re-landing capability. So this decision of Sevilla is a first step of focusing on cargo to bring cargo up on the space station. Again, we will not apply georeturn in the first phase of developing this vehicle. We will be an anchor customer. That means industry can develop as they like this future cargo vehicle. And this, of course, again, is good for competition, is good for challenges, therefore should be a good technical solution. Industry can be very innovative to come up with proposals, and we want to be very fast. I would like to, of course, assuming decisions at the IPC next week of the ESA Industrial Policy Committee by our member states, but assuming this decision is given, I would like to open this competition before Christmas, and then, of course, industry will offer its proposal or their proposals to us. I hope we can evaluate them by spring next year and sign them in spring next year so that industry can really work. By 2028, we would like this service to be available, that we as anchor customer can buy the first flight. And that is very challenging. That is actually more challenging than what you have probably seen in other countries, in the US and in similar circumstances. I think Europe is moving very fast in this activity. Again, this is a game changer because we are not defining the capsule in all details. We are not giving all the technical specifications. We just say, bring up 4 tons to the space station, bring down 2 tons, dock on the space station. Of course, once the space station is out of service, as we expect to be after 2030, the same docking mechanism need to be available or should work on commercial space stations. So this is really a recurrent service that should come up in the future. Again, as ESA, we are stimulating the supply, we are stimulating the industry. We will be an anchor customer, so therefore with this guarantee or with this promise of us being an anchor customer, the companies can acquire money from the open market, from venture capital companies or other banking or funding institutions, and therefore really bring fresh money into the space segment, which I think is very important. In addition, of course, to fostering innovation, really pushing innovation very hard. Of course, ESA will always develop technology. ESA will always make sure that we are focusing on shortcomings or issues that we have from a technology point of view in order to help these companies succeed and accompany them along the way. And these really have been quite important decisions. Of course, if I say that we have today a vehicle that brings cargo up, we will hope that the proposals we get back from industry will be designed in a way that they could eventually be expanded to transport astronauts. Of course, the decision for astronaut flight is not yet made, just to be crystal clear, but we would hope that the vehicle can develop in the future from a cargo vehicle to a crew vehicle, as we have seen it also in the United States, for example, with the cargo and the crew Dragon, which is flying today successfully. So I really think, again, this was a watershed decision, which was made in Sevilla, with a very new way of working, where we work as an anchor customer. Also within ESA, we will be a very agile, fast procuring agency. I will create a tiger team within ESA, which is following this procurement. And this will be quite exciting moments, I think, for Europe to really push forward and push upwards and accelerate space in Europe. Ladies and gentlemen, thank you so much.